morning everyone and welcome to the NPTEL course Advanced Distribution System Analysis and Operation. We are continuing with our module 8, that is DER Integrated Distribution Network Fault Analysis and Protection. Okay, till the last class we have seen that what is the effect on the fault current due to the DER. So, we have seen that how to classify, identify and locate a fault, and then we have seen that what is the impact of the fault current. So, today on how you can do the relay coordination, right, about the overcurrent relays, directional overcurrent relays, how you have to make them adaptive relay coordination. So, today we will see the outage management system. That means, if you already incur a fault, you have a fault in place, it may be a temporary fault or maybe a permanent fault. Irrespective of that, how your system can be managed so that that outage scenario can be overcome easily. Okay. So, first you will see that what are the main causes of power outage. The most of the time the main causes are the bad weather is the most frequent cause of power disruption. That means a bad weather hazard, something happened and that causes that your power failure. Sometimes some lines has been broken or some poles has been fallen down. So, this things keeps on happening if you have a bad weather condition, that means very high wind, let us say hurricane condition or storm or wind loading or ice storm, your ice storm. So, if these things happen, so you will have a power outage. So, multiple factors may contribute to a blackout simultaneously. Okay. So, what are the bad weather related events? First, lightning can knock down trees onto the lines or damage the transformer because of the lightning strikes. These are very common scenario. Flood or mudslide result from heavy rain and can damage the infrastructure. Extreme temperature harm electrical grid component, that is, if you see that it is very hot weather. So, already due to the power flow your line temperature will be heated up, then because of this extra ambient temperature your line will be more heated up. So, that will reduce the thermal capacity or enhance the power or reduce the power capacity limit of the line, and it will hit the thermal limit of the line with a very low power flow. So, if that is the case, then you have to cut down some of the loads. So, then they will experience the power outage. Then survey data on the large outages, it is shown the 3% because of the lightning, 5% because of the snow and the ice, and 8% because of the wind, and this combine if you see almost 16% because of the weather conditions. Now, what are the other causes? If the system experience very high load, if your system is experiencing overloading condition, at that time your line capacities are already full, you have no other way option to shut the load off or do the load shedding. Then human error by mistakes, the grid operation or the maintenance. If there is any mistake by the humans or the operators, then also people experience power outage. Vandalism or theft, stealing, copper wiring components causes localized outages. Other natural causes like earthquakes, wildfires and a flood, that also can destroy the lines, substation transformers and cause the major regional outages. How they are affecting, that we will see in our next module, that is the resiliency module. So, types of power interruption. First, it will be blackout, that means complete grid failure, that is nothing is left, the entire grid will be shut down and no customer is getting power. Then there will be brownout, that is called temporary voltage drop to prevent the full blackout. That means the grid is under stress condition, grid is experiencing lower frequency depending upon the reference frequency, and also the voltage sag or the voltage dip is very high, but still the system is running. It is not that everything is shut down, everything is cut out, it is not the case. It is experiencing a stress condition, but it can be overcome with the help of other means or the backup supply. Then if you have a permanent fault caused by the current voltage imbalances or needs manual fixing, that means if you have a fault condition, then at that time you also have to operate your relays or the circuit breakers or other protection devices to isolate the faulty section and keeping the healthy section operative. So, what are the consequences of power outages? First we will see the technical consequences. Distribution power losses. That means increased technical and non-technical losses in the grid due to the disruption of normal power flow. So, you thought of that the load will be catered with the shortest path with the lowest electrical distance or lowest resistance or impedance, but due to the power, let us say a fault occurred in the shortest path and now the power has to go or wheel through the longer path. So, at that time obviously the system loss will increase. Then the voltage and the frequency instability, power quality issues that can damage sensitive equipment. That means because of that stress condition your frequency will reduce, your voltage will experience a dip. So, that will cause your power quality issues. That means which are very voltage and frequency sensitive equipment, they will not operate accordingly, they will operate bad manner or malfunction. Component stress, frequent outages shortens the lifespan of the transformers, switchgear and other grid infrastructure. If you can see the distribution transformer, normally we compute their all day efficiency, because distribution transformers are designed that it has to be on or it has to operate full day. But if you multiple times, let us say within a day 2-3 times power outage is happening. So, the transformer is multiple times energized, de-energized, de-energized, energized, multiple times these things are happening. So, the core of the transformer will experience a stress. If that causes, then obviously the life of the distribution transformer will reduced, right. Then unreliable service, reduced system reliability reflects in metrics like SAIDI, SAFE and KD. So, that we have studied already in our reliability study. Then economic consequences, obviously with the technical, if you cut down your customers from your supply, that will cause some loss of the monetary loss also you will experience. So, financial losses for business. So, downtime in manufacturing, IT services and retail leads to loss of revenue. Operational costs, need for backup generators, fuel and additional labor. So, if you have a critical customers, let us say you have a hospital, so or a big government office, so at that time you cannot afford to have a power cut to those critical customers. So, as a distribution utility, so at that time you have to turn on your backup supply, that means a costly energy producer. That means you have to turn on your diesel generator or you have to take power from your storage, everything is costly because storage installation needs a huge capital investment. So, that is the cost, that means your operational cost will be boosted. National economic impact, countries report up to 30% of the business sale loss due to the outages. Obviously, so if your power is not there, all the industries, all the facilities depends upon the electrical power. Value of lost load, so represents the economic cost per kilowatt hour of unserved electricity. So, obviously, you have to pay your customers, like if it is a demand response program and at that time you are shedding the loads of your customers. So, at that time how much load you are not satisfying, as an utility you have to give reward or you have to give penalty to those customers who are suffering. So, that is the also a economic loss to the distribution utility. Apart from that, you have social and consumer level consequences. What are that? Disruption of the daily life affects residential heating, cooling, cooking and the communication. You have public safety risk, that is inoperable traffic signals, street lighting and security systems increase the accident and the crime risks. Healthcare impacts, hospitals and clinics may face life threatening situations without reliable backup power. So, if you do not have power, obviously the life, because we are now very much dependent on the electricity. So, if it is not there, that will impact the your social society as well and the social life of the humans. Environmental and development impact, increased use of polluting generators, diesel generators used to during outage increase emission. So, if you are losing, let us say with a power outage, because of the fault you are cutting, you are islanding one section and that has some DERs. So, you are losing those cheap powers because you have incurred a power outage and now you have to turn on your diesel generator to cater the critical loads. So, that will impact the environment as well. Slowed development, power unreliability hinders industrial growth, education and health services in developing regions. So, now how you can overcome this problem? So, power outage most of the time it happens because of the over demand condition. When the load is becoming very high At that time what will happen? Your voltage will dip, your frequency will dip. If that happens, so at that time system will take more and more current, because most of the powers we know those are the constant powers. So, it is V I. So, if your voltage dips, so at that time current will increase. If the current increase, then in the line, if you have a line here with the impedance Z, then the I Z drop will increase. If the I Z drop will increase, then the receiving end voltage will further decrease. So, it is a cascading effect, and because of that after some time you will experience a power outage or out of synchronism operation. So, to prevent that, what kind of remedies or what kind of strategies a distribution network operator can adopt? The first one is the demand side management. What is that? The demand side management says that you give the customers some options or some intelligent energy price rate that that will attract the customers and motivate them to use more power when the system is not under stress condition, that means not is under peak load condition. That means normally in the customer level we take the flat pricing. So, if it is a 6 a.m. time and this is your 12 p.m. time, and then you have your let us say 12 a.m. time. So, all the time your price is constant. Okay. So, that means it is not motivating. I can turn on my load at 6 a.m., 12 p.m., 12 a.m. anytime. Okay. So, if your load curve is like this, that means you have a peak load between 6 p.m. to 9 p.m. and if you follow this flat load curve, then as a customer when I am coming back from my work, I will turn on all my electrical appliances between 6 to 9 p.m. So, adding more loads during the peak hours, and that will overburden my system. So, then your flat rate price is not an effective solution. Rather than that, if you take a time of use price or real time price or any kind of dynamic price, then what you will say that okay, when it is off peak time your price will be low, but when it will be on peak on time then your price will be very high. So, if you have this kind of a dynamic price, so what will happen at that time? You will as a customer, to reduce your electricity bill, you will think or you will see that okay, I will not turn on the my equipment now, I will wait for the lowest price time. So, if that is the case, so by intelligent energy rates with motivators for specific utilization arrangements, and finally to current continuous management of allotted energy resources. So, at that time you can use, even when the solar power generation is very high at the daytime, you motivate the customers to use the maximum amount of load at the daytime with that free energy, that will not create burden on the distribution grid. So, demand side management is one option. Second option, obviously you can change your generators, like you can change the setting of the generators depending upon to meet the load. Okay. So, first you can take the automatic generation control which compares the actual output of the scheduled values, you tune that AGC, compute set points for each unit or plant handles unit ramping for new scheduling needs, that is at the transmission grid, because ultimately the distribution load will be reflected to the transmission system, and accordingly you set your generators to cater those extra load. Flexible generation control, generation management system receives dispatch instructions from ISO and RTO, that means independent system operator or remote terminal operators, calculates and transmits specific set points to generators. Scheduling operators can modify day ahead and hour ahead schedules, align generation with utility bidding and scheduling needs. That means you just see every time, even if you calculate day ahead schedules of your generators or if your storage as a network operator, but even intraday or hour ahead or 15 minutes ahead, you again calculate your real time situation, and depending upon that, to avoid any power imbalance or any, you can say, deviating from your economic scheduling, you just see whether you are at the economic point or not, or whether your customers, whether the load prediction whatever you have predicted, that is following your forecasted data or not, the real time one, that is following your predicted data or not. Then advanced metering services monitors actual energy delivery from generating units, ensure compliance with the contracts or obligations. That means if you have a large industrial customers or commercial customers, always there is a bilateral trading, or you can say there is an agreement between the network operator and the customer, big customers, that how much power they will take at every day or each and every hour. So, with the metering infrastructure you can see whether your customers are obeying that agreement or the contract or not, and if they are not, then you can set the penalty for them. Okay? Or if for them, if they are said that okay, we will install a local capacitor bank at our place which will inject the reactive power and that will boost the voltage level at the connecting bus, but if they are not doing it, that means they are they are deserve some penalty cost. But if they are doing, that means they are helping the grid to overcome the stress condition. So, if that is the case, then they deserve a reward. So, depending upon that you can take the metering infrastructure. Real time data collects data from internal plant sites and ISO, enables dynamic decision making and control. Energy accounting supports after the fact analysis of the generation, tracks generated megawatts and time based outputs. Emergency generation requirements ensure readiness to meet unexpected needs, covers situations like resource rejection, curtailments and layoffs. So, these things you can adapt at the generation side, which is mostly done at the either at the transmission grid, or you can take if you have a diesel generator there in the distribution network, or if you have a storage. So, depending upon that you can modify its schedule or you can modify its operation. So, this is the overall schematic of the outage management system. You need the geographical information because you always have to know where the customers are, what are the geographical challenges you have there. Okay. Then you have to have an web map that will say that which kind of equipment, how many transformers, how many lines, everything you have in your distribution system. Mobile workforce, that is your communication system. You have automated meter infrastructure, you have a supervisory control and data echo SCADA system, obviously that will give you the real time measurements, and with that also you can have the PMU system as well in the distribution system, which is every time which will give you the real time updates of your system. Then interactive voice response, that is with your neighboring substations. Then customer information system, which will give you if there is any fault or the customers are dissatisfied with your supply or with your service, then they can directly complain and you will immediately you will come to know if something happened with your system. Then engineering analysis. So, it is like every time, every certain period of time you do take proper analysis of your entire system, that whether the system is running properly or not. If something is, if some equipment is degrading, if some equipment is on the verge of completion of its lifespan, then those things you can do only by doing the engineering analysis. This can be reliability analysis, it can be power flow analysis, that can be fault analysis or any kind of analysis. Okay. So, in between that 4 are actually the major dominating things, that is the customer service system, which will collect the customers outage reports and service requests, enabling rapid identification of outage location and the customers impacted. So, if some transformers has been burnt out or been struck by lightning, so immediately that news will come to the network operator through the customers. They will only call to the utility or the you can say customer care and inform them that okay, this happened. So, that is the real time information. SCADA system delivers real time data on grid operations, including the status of electrical lines, equipment and support effective monitoring and the control of the network. Then you have GIS system, provides comprehensive network topology and asset data, including maps and spatial relationships to accurately locate an outage access to the network's configuration. Then you have advanced metering infrastructure, enables automated detection of outages through smart meters that transmit instant feedback. So, that means if your some customers are cut out and all the time you have a two-way communication, suddenly if you see that okay, my 100 customers they are not sending me data, that means smart meters are not communicating with the central controller. So, immediately we will come to know those 100 customers has been disconnected by some means because something happened to them. So, immediately you can take action and you can start investigating that what is the reason of power outage. Okay. So, the flow of outage management system is that you will get your information from your customers to the call center. Then with that outage management system, you will predict, group, prioritize and estimate time of restoration, and then escalate your restoration option. Okay. Then you send the data to the SCADA and see whether actually this happened or not. Sometimes you get false calls as well from your customers. So, with this, first you see, analyze the outage one and see whether the SCADA system is giving you the same data or not, and also the GIS system. The SCADA and the GIS system is giving you the same data or not. If that is verifying that okay, whatever the customers reported and my system also responding the same thing, then you then as a DNO you will inform your zonal office and then the field crew to the service restoration process. So, you have normally two kinds of restoration process. One is the temporary restoration, that is mainly relies on the reconfiguration. That means, one line is going out of order, or one pole is you know that is like fallen down on the ground, or some transformer that has been struck due to lightning, or any fault occurs, anything happened. So, at that time you always have a wheeling path or alternative path to cater the few customers. Normally distribution networks are radial in nature, but it has so many normally opened switch. So, what is the purpose of that normally open switch? To do the network reconfiguration. So, whenever you need, those paths are not economics, those paths are not loss minimized, or those paths will not give you the lowest electricity bill or energy cost, but those at least they will help you to cater your far end loads with an alternative energy path. So, that is a temporary solution that you can take immediately, because restoration, that is the emergency actions or isolating the fault currents, that means to service the completely restored the service, that means by fixing all the damages, that will take time, that will take few hours, that will take few days sometime. But you cannot afford to let your customers be in dark or without power for those few days, because that will reduce the system reliability and customers will become dissatisfied, unhappy with your service. So, at that time you can take temporary reconfiguration of your network and cater the loads within few hours or few minutes time. Okay. So, you can do the fault diagnosis and the restoration process. Transient faults are managed by automatic reclosure. So, if you have a transient faults, you can take the automatic reclosure, like you can just remove that line and then add another line and check whether your fault is removed or not. If permanent faults or overloads, require manual isolation and cannot be restored until resolved. So, if it is a permanent fault, if it is a sudden fault, transient fault, then the reclosure like circuit breaker will open, and after some time it will again try to close, and within that time if your fault has been removed, then it is fine, then it will be intacted and the power supply is good. But if it is after 3 times, the reclosure normally tries to close the circuit and 3 times. If that fault persists to that 3 times as well, so at that time we say that is a permanent fault, and at that time your circuit breaker will be completely, like it is permanently opened and the circuit is completely disconnected. So, at that time you need the manual isolation or you need the manual restoration. That means, the crew has to go there, it has to check what is the fault condition. So, then that services is called. SCADA system help to collect and interpret fault and status data. Manual field inspection may be necessary to confirm fault location and the condition. So, these are the restoration steps. First, you will diagnose and locate the faults, then you isolate the faulty section or faulted element, re-energize after you disconnect them, then try to, if it is a transient event, then automatically that will go after few cycles. So, again you check re-energize a non-faulted section using rerouting or the reclosing. So, after some time you do the reclosure, operate the reclosure and see that whether the fault is gone or not. If it is not, if it is a permanent fault, then do some rerouting of the power to give the supply to the de-energized customers. Then implement a restoration solution until full service is recovered. So, what are the objectives of your restoration? primary goals is to maximize the service to the affected customers and restore service as quickly as possible. So, that is the under the faulted condition we do not see for the loss minimization or the cost minimization algorithm. There we see to maximize the customer satisfaction or minimize the restoration time. Feasibility requirement must avoid causing further outages during restoration. If it happens that let us say your another alternate path which you chose for rerouting the power, let us say that path is already overloaded. That means that is catering few customers. Now you added that extra load to them, so that will cause another failure of your system or another fault. So, that should not be there. So, you have to consider that if you are rerouting your path, so at that time other equipments like who are taking the responsibility of that extra power, they should not be overburdened or they should not undergo to the fault condition. So, operating conditions are more constrained than in normal state, because few of your system facilities are going out of order. So, other system has to take the responsibility. So, that means the system conditions are becoming more and more stressful. Okay. So, relaxed constraint during restoration, loss minimization and load balancing are deprioritized. That means you can cut down also few loads if it is a flexible in nature. So, you can cut down them and loss minimization is not your concern now. Voltage limit and the loading constraints may be temporarily relaxed. That means, if you see that your voltage must be within 0.95 to 1.05, which we have seen for the ANSI and the IEEE standards, but if it happens that during the faulted condition you can allow this voltage to go to 0.9 per unit. Okay. Or we have seen the IEEE standard which says that you can run your system for few times short time interval even in the 0.88 per unit as well. Okay, so, the voltage limit is relaxed and also the loading constraint, that means the line. So, few lines always have, all the lines have some overloading capacity. So, we relax that and we keep few lines overloaded, but you have to keep in mind that that overloading condition should not lead you to a cascading failure situation. Overloading of transformers and feeder can accelerate aging and cause damage. Okay. So, restoration time and overload limits. Restoration durations typically range from 4 to 14 hours. Long duration overloading must be limited to avoid equipment damage. Okay. Overcurrent protection settings are influenced by ambient temperature, cooling methods and utility specific practices. So, these are the consideration people take whenever they do the protection or restoration services. Okay. So, what are the key takeaways from there? That power outages are major failures in electric power systems with serious technical, economic and social consequences. Outages can be caused by bad weather, equipment failure or human related failures, and we detect, locate and identify the outages section or outage or faulted section, we have to detect it very fast, so that that can be segregate or isolate from the normal healthy supply, and that we do with the smart metering service, we can do with the geographical information, we can do with the SCADA system, or we can take the direct feedback from our customers. And during the network restoration process, when we reroute the power to the customers by with the help of reconfiguration, at that time we do not consider the loss minimization or the economic consideration as the primary objective. We take the system reliability or customer maximization of the customer satisfaction or minimization of the interruption duration as our objective function. And efficient outage handling and restoration are crucial for ensuring your grid reliability, minimizing downtime and improving the service resilience. Okay. With this, I will end today's lecture and will continue with this fault condition or other means in the next lecture. Thank you.